continue our study of the patterns involved with exponents by looking at division properties of exponents. We're going to simply start looking at examples where we have the same base raised to a power divided by that base raised to a power. So let's take the example of 2 to the 7th over 2 squared. You can visualize this problem if you were to expand it by writing the numerator 2 times 2 times 2 times 2 times 2 times 2 because the base is 2 and it appears 7 times as a factor. In the denominator 2 to the 2nd power, we have 2 times 2. You can clearly see that 2 factors of 2 cancel, leaving you with 5 factors of 2, and your final answer is 2 to the 5th power, which is 32. There is a division property of exponents that you can use, however, without having to expand your monomial. In this case, it's 2 to the 7 minus 2. You have 7 powers of 2 on the top, 2 factors of 2 on the bottom, leaving you with 2 to the 7 minus 2, or 2 to the 5th power, and this gives you the same answer. As with multiplication properties of exponents, if you forget the rule, expand the problem by writing out your powers and then look for your patterns. Another example that involves more factors is d to the 4th e cubed over d times e squared. Now, before we start subtracting, let's look to see if we can simplify the problem any further. When you see in the denominator d e to the 2nd power, we can apply what we know about multiplication properties of exponents. And we're going to write this as d squared e squared because de is your base and it appears twice as a factor. Now we have d to the 4th on top, d squared on the bottom. So we'll be using the base d, subtracting the exponent 4 minus 2. The other base that you see in this problem is e to the 3rd over e squared. So we'll write e to the 3 minus 2. Now we simply subtract. 4 minus 2 is 2. 3 minus 2 is 1, so our final answer is d squared e to the 1st, which is just d squared times e. One more example at this level. Looking at the problem, 3 times 4 to the 3rd power times 5 to the 5th power over 3 squared times 4 to the 4th times 5 to the 3rd power. Notice I put multiplication dots in between the factors to remind myself these are separate factors. I've also lined up the like bases. For example, the factors of 3 are lined up, the factors of 4 are lined up, and the factors of 5 are lined up. Now I'm simply going to subtract. Remember, the factor of 3 can be written as 3 to the 1st power. So that gives me 3 to the 1 minus 2 times 4 to the 3 minus 4 times 5 to the 5 minus 3. And when you subtract these exponents, you're going to have some negative exponents for an answer. So 3 to the 1 minus 2 becomes 3 to the negative 1 because 1 minus 2 is negative 1. 4 to the 3 minus 4. Again, 3 minus 4 is negative 1. So we have 4 to the negative 1 power. And finally, 5 minus 3 is 2, and we have 5 squared. And we've learned how to simplify these. Our negative exponent simply means we're going to write the reciprocal. So in the numerator, we have the positive power of 2, we have 5 squared. In the denominator, 3 to the negative 1 becomes 1/3, so that goes to the denominator. 4 to the negative 1 becomes 1/4, so that's also part of the denominator. My final step in simplifying is to simplify 5 squared, which is 25, and 3 times 4, which is 12, and my final answer is 25 over 12. We can use these same properties when working with problems that are written in scientific notation. In this example, we have 3 times 10 to the 10th divided by 6 times 10 to the 6th. we're going to write this in fraction form with 3 times 10 to the 6, and then, or excuse me, 3 times 10 to the 10th in the numerator, and 6 times 10 to the 6th in the denominator. Looking at each part of this, we can break this into 3 over 6 times 10 to the 10th over 10 to the 6th. Now, 3 divided by 6 is 1/2, which can be written as 0.5, and 10 to the 6th, excuse me, 10 to the 10th over 10 to the 6th becomes 10 to the 10 minus 6, or 10 to the 4th. Now I've got the problem 5/10 times 10 to the 4th. However, this is not written in scientific notation. To write this in scientific notation, I need to move my decimal point 1 spot to the right, which is the same as multiplying by 10. Is that going to raise the exponent or lower it? Will that make it 5 times 10 to the 3rd or 5 times 10 to the 5th? If you're not sure which way to go with your exponent, take it apart. Think of the number 5/10. How do we write 5/10 in scientific notation? 5/10 written in scientific notation becomes 5 times 10 to the -1, because we're moving the decimal point 1 spot to the right. We still have a factor of 10 to the 4th. So we're going to multiply this times 10 to the 4th. When we combine our exponents, because we have the same base, which is 10, we're doing -1 plus 4, which gives us 5 times 10 to the 3rd, and our number is written in scientific notation. Let's pull up another level. In this level of examples, we're going to look at fractions and how we apply the division property of exponents using fractions. Before we look at the rule, let's look at the problem. In this case, we have 4/7 to the 2nd power, which we know can be written. The base is 4/7. It appears twice as a factor, so we can write it as 4/7 times 4/7, which equals 16/49. Using our division property of exponents, however, we can think that 4/7 to the 2nd power can be rewritten as 4 squared over 7 squared. Again, 4 squared is 16, 7 squared is 49, we get the same answer. In general, if you have a fraction, for example, x over y to the nth power, you raise the numerator to the nth power and the denominator to the nth power. Another example with 4 factors. 3d squared over ef to the 4th power. Now, before we apply the exponent of 4 to the numerator and denominator, we want to check to make sure there's nothing to do inside parentheses. One thing you need to look at is we have factors inside the parentheses. So let's rewrite this as 3 times d squared over e times f, because this exponent of 4 gets applied to every factor in the numerator and every factor in the denominator. Applying that exponent of 4, we get 3 to the 4th times d squared to the 4th power, we learned, is d to the 8th power, because we multiply the exponents. And we put that over e to the 4th and times f to the 4th. Let's take one more step to simplify. 3 to the 4th power is 81. And then we're going to take away our multiplication dots, because it's understood that we're multiplying if the coefficient is right by the variable. So that's 81d to the 8th in the numerator over e to the 4th, f to the 4th in the denominator. And this is our simplified answer. One more example of this level. Lots of examples make for good understanding. 2x to the 3rd over xy to the 3rd to the 2nd power. Once again, we're going to look to see if there's any work to do inside the parentheses. I'm going to rewrite 2x to the third power as 2 times x to the third power. And in the denominator, my xy raised to the third power becomes x cubed y cubed because the exponent is applied to each factor. We're raising all of this to the second power. So at this point, you could take each factor to the second power, but hopefully before you do so, you look at what's inside parentheses. I have a fraction inside parentheses that has some common factors. Remember, you can cancel before you multiply, so I'm going to divide the top and bottom by x to the third power because that's a common factor. That leaves me with a factor of 2 on the top, so 2 squared on the top. And in the denominator, I have y to the third power, 2 that is also squared. That becomes y to the 6th power. My final step in simplifying is to write 2 squared is 4, and my denominator remains y to the 6th power. My last set of examples are going to involve negative exponents. Remember, a negative exponent means I'm going to write the reciprocal to the positive power. So starting with something rather simple, I have a fraction raised to a negative power. You know, the negative sign means I'm going to flip it or write the reciprocal. So I'm going to rewrite this as, flipping the inside, 4/3 to the third power. Then I'm going to apply the exponent to the numerator and to the denominator. 4 to the third power is 64. 3 to the third power is 27. There's my answer. Our next example has more than one factor. 2x squared over y cubed all to the negative, excuse me, this should be negative 2 power. First, I'm going to see if there's any work to do inside parentheses. There is not. There is no simplifying that I can do, but I can put a multiplication dot to separate the factors. My next step is going to be flipping that fraction or writing the reciprocal. Once I do that, I've taken care of that negative sign in front of the exponent. Now it becomes y cubed over 2x squared to the second power. And now apply that exponent of 2 to the numerator and the denominator. So y cubed to the second power becomes y to the 6th over 2 squared, which is 4, and x squared to the second power, which is x to the 4th. My final answer is y to the 6th power over 4x to the 4th. My last example will be a little bit more involved. I have 2/3 to the negative 2 power times 6m over 2n to the negative 3rd power. First, I'm going to look at 2/3 to the negative 2 power. There's no simplifying to be done inside the parentheses, so I'm going to write the reciprocal, which is 3 over 2 to the second power. Looking at my next fraction, there is simplifying to do. Notice 6 and 2 have a common factor of 2. So 6 divided by 2 is 3, 2 divided by 2 is 1. This gives me the fraction 3m over n. But I'm going to write the reciprocal, so I'll put the m in the numerator and the 3m in the denominator. And now I'm raising it to the positive 3rd power because I've written the reciprocal. Before I start multiplying, I am going to notice another common factor. So in this case, I have 3 halves times 3 halves here. And in the next section, I have n times n times n, or n cubed, over 3 times 3 times 3 times m times m times m. Why did I write it that way? So that you would notice we have a common factor of 3. In fact, we have 2 common factors of 3. What does that leave? Well, in the numerator, that leaves n times n times n, which is n cubed, over 2 times 2 is 4, times 3, 4 times 3 is 12, and then I have m appearing as a factor 3 times, so So my final answer is n cubed over 12m cubed. Could have done the same thing with subtracting my factors. However, in this case, I thought it made more sense to write it out. That's all of the lesson for today. You'll be practicing many problems of this type. Thank you.